are going to study chemistry subject, and the chapter we were dealing was the aliphatic hydrocarbon. Now this is session number 5. Now in session number 4 we were started with the topic so called as alkene or olefin, wherein we studied about the definition of alkene. Apart from that, we were started with the preparation technique. The first preparation technique we begin with was dehydration, which was saying that whenever the alcohol was undergoing dehydration, it was giving you olefin, right? And accordingly, the Sedzif rule was applicable over there in order to remove that hydrogen group or the OH group from the respective carbon atom, right? So how it will be going to get removed off, that we have been studied by applying the Sedzif rule over there. Now here we are going to start with a new topic, which is dehydrohalogenation. Dehydrohalogenation. This word has the important words which are hidden within it, and it gives or imparts meaning to that topic, right? So what is that word? D means what? D means removal, okay. Hydro means hydrogen group. Halogenation means halo group. So here D, removal of hydro group and halogen group will be going to take place from the group so called as, from the reactant so called as alkyl halide. So from this alkyl halide, the removal of hydrogen and the halogen will be going to take place, and after removal of that two important group from this reactant, you are going to obtain or yield olefin or alkene over there, right? So this is the second methodology of preparation of alkene from alkyl halide by dehydrohalogenation process, right? So how this process will be going to take place, let's see over here. Now in this process, the most important reactant, no doubt it is an alkyl halide, right? So when alkyl halide has to react with a certain another reactant, then only you are going to obtain or yield alkene over there. Now what is the second important reactant that we are going to study over here? Now when alkyl halide heated with alcoholic solution of potassium or sodium hydroxide. So here alkyl halide will be going to get heated up with alkalis like sodium hydroxide or potassium hydroxide to yield alkenes by a process called as dehydrohalogenation, right? So what is that saying? When alkyl halide is heated up with alkalis so called as sodium hydroxide or potassium hydroxide, it will undergo dehydrohalogenation to form an alkenes, right? So this is a very, very simple reaction. Let's hit it over here. Now here in that, which carbon will lose halo group, which carbon will lose hydrogen group, that also we need to understand. So while writing down the general reaction, you guys will understand more precisely over there. So let's write down the general reaction over here. So alkyl halide, first thing is that alkyl halide need to be treated with potassium hydroxide, alcoholic potassium hydroxide. So let's take one alkyl group over here, okay. So alkyl halide, when I am going to treat, okay, now this is the halide group and this is the hydrogen group. Now this is the alkyl halide, right? So this halogen group, which is the carbon to which the halogen group is attached, that is considered to be the alpha carbon, and the carbon to which the hydrogens will be there neighboring to alpha carbon, the beta carbon will be there, right? So alpha carbon will be that carbon to which the halo group will be attached. That is an important point, right? So the alpha carbon and the beta carbon, they are going to get attached with each other by bond between them, we know that, and then that need to be treated with the potassium hydroxide, alcoholic potassium hydroxide. This will be going to get heated up to form an alkene by dehydrohalogenation. So start removing the hydrogen group and the halo group from the reactant. So I am going to remove the hydrogen group from the beta carbon and the halogen group from the alpha carbon. The alpha carbon, which is losing the halogen group, it will be going to go and get combined with this potassium, right? And the hydrogen group, which is going to get removed off from the beta carbon, it will go and get combined with this hydroxyl group, right? So after removal, what the product will be going to get formed, let's see over here. So once those groups are going to get removed of hydrogen group, hydrogen atom and the halogen atom from that respective carbon atom, this bond will be going to get broke and the new bond will be going to get formed. So any chemical reaction, it's undergoing or processing, there the breaking of bond has to take place and the making of bond will be going to take place. So here the breaking of bond will be going to take place first, followed by making of bond. So once these groups are going to get detached from the respective carbon atom, the bond will be going to get broke and the new bond will be going to get formed like a double bond, right? So these two groups have been removed off and the double bond will be going to get formed over there, right? So what we found over here after removal of the hydrogen and halo group from that, the name of this product is alkene, double bonded carbon atoms, right? It's nothing but considered to be the olefin or the alkene, and side product or the byproduct is nothing but this halo group will going to get attached to the potassium to form potassium halide, and this hydrogen will combine with this hydroxyl group to form H2O, right? 2 hydrogen and oxygen water, right? So this is how dehydrohalogenation of alkyl halide is taking place to give you alkane in presence of the second reactant, so called as alkylase potassium hydroxide. Okay, so that was the general reaction which I shown you guys. Now let's go towards the main reactions. Examples will go through one by one. Examples for this reaction. Let's take the example number 1. Now I am going to take the example number 1, so called as methyl, sorry, not methyl, we'll take ethyl group, okay? So ethyl bromide. So this is the alkyl halide, right? So the name of this reactant is ethyl. Why so called as ethyl? Now see this, C2H5, C2H6 was ethane. Now if one hydrogen became less, it has been converted into alkyl group, so called as ethyl. So from ethane it has been converted into alkyl, right? So initially I said you guys that ethane means alkane and alkyls are sisters. Only one hydrogen is becoming less, that will be going to get converted into the alkyl group, right? So this is the ethyl. Now the halo group which we have been attached over there is bromide, ethyl bromide. So this ethyl bromide, when it is reacted with the potassium hydroxide, alcoholic potassium hydroxide, they are going to get heated up. Okay, now here the alpha carbon will be that carbon to which the halo group will be attached, and the beta carbon, from that the hydrogen group will be going to get detached from it, right? So this hydrogen group, when it is going to get detached from the beta carbon, it will go and get combined with whom? It will go and get combined with the, yes, hydroxyl group. And the, bromide halogen group will go and get attached to this potassium, will go and get attached to the potassium to form potassium bromide. So what is left is nothing but the main product, which is so called as alkene. Okay, so once those groups are detached, after the removal of that group, hydrogen is removed, yes, the double bond going to get formed. The bromide atom is also going to get removed. The double bond will be going to get formed over here. So the bond breaking will be going to take place. Then only the formation of double bond will be going to take place between the alpha carbon and the beta carbon. So these two hydrogen will be going to get remain unharmed, untouched. These 4 hydrogens, they are going to remain untouched. these two groups will be going to get detached. Okay, so and the byproduct which is going to get formed over here, this bromide atom will go and get attached to this potassium to form potassium bromide, and that hydrogen atom will go and get attached to this hydroxyl group to form a water, right? So the alkene which has been formed over here is C2H4. C2H4 is which alkene member? This is the member so called as ethene. Ethene, the first member of an alkene family beginning with ethene, with the formula so called as C2H4, right? So this is how the alkene will be going to get formed when the dehydrohalogenation of ethyl bromide will be going to take place. Now let's take the another example, second example. This is quite simple one. Now little by little we'll just make it complicated by taking a complicated example. Okay, but that complicated examples are also very easy. If you understand the concept, it becomes so simpler for you guys. Okay, now let's take the second example, okay, with the 3 carbon atom into it. 3 carbon atom alkyl halide I am going to consider over here. Okay, second example. So 3 carbon atom. Okay, now in the second carbon atom I am going to attach the halo group. Let's take bromo group, bromide, and the remaining, yes, balanced with hydrogen. So this is the alkyl halide, and the name of this alkyl halide is second carbon. It is 1, 2, 3, 2 bromo propane. This is the IUPAC name, or this is also called as isopropyl bromide. Isopropyl bromide. It is also called as isopropyl bromide. Either way around, whichever you want to write, you can write down, right? Iso, why? Iso is nothing but at the second carbon, whichever group will be there, methyl group, ethyl group, or whatever, or the halo group. So that will be going to get come backside. So the main alkyl group, that is propyl group. Okay, so that is isopropyl bromide or 2-bromo propane. At second carbon, bromo group is there, and the alkane, parent alkane is propane. This you have been studied in your PUC. Okay, IUPAC nomenclature. So now this, when it is treated with alcoholic potassium hydroxide, it will be going to get heated up to form an olefin over there or alkene over here. So now we need to understand, now we know that the halo group will be going to get attached to the carbon atom. That carbon atom is considered to be the alpha carbon atom, and the beta, it's your choice. If you want to take this beta first, okay, then this beta also okay, because 3 carbon atom, this will be considered to be the symmetrical one, right? Initially if you are starting with here, the numbering should be like this. So after 3 carbon atom, whichever the compound will arises with the butyl halide, that time we need to apply the rule so called as Sitzif rule over there, which will be considered to be the major product and which will be considered for the minor product that we have been studying in dehydration process. No, the similar one here we are going to study over here also. But till 3 carbon atom, it's your choice, whichever the alpha. But remember, the halo group will be going to get attached to the alpha carbon only, right? And the neighboring one, beta, whichever you want to remove the hydrogen atom from the beta group, you can take it out. That is applicable only for the 3 carbon atoms, the compound with the 3 carbon atoms. Okay. Now here the alpha carbon will lose the bromide atom, the beta carbon will lose the hydrogen atom. Yes. So this bromide atom will go and get attached to whom? Potassium, to form potassium bromide, and this hydrogen will go and get attached to whom? Hydroxyl, right? Hydroxyl atom, hydroxyl ion, to form the water molecule, right? So whatever is left over there, that will write down over here. So the remaining one, CH3, that is not going to, the terminal carbon, the first carbon atom is not going to get disturbed out. Then the second carbon atom, here once this group is going to get detached, the bond will be going to get broke. here also the bond will be going to get broke, and it will lead to the formation of double bond between carbon number 2 and carbon number 3, right? And from here the two groups has been vanished, detached from there, right, and leading to the formation of the important olefin whose name is 3 carbon. 3 carbon is there, and totally 1, 2, 3, 4, 5, 6 hydrogen is there. So 3 carbon oriented, member of an alkene is propene, right? So the name will be as such, prop 1 means why I am giving the 1 over here, because we will start with the like this. So it will becomes the lowest preference 1 you have to write down. So prop 1 in. Prop 1 in will be the olefin, which is an alkene, and the byproduct which has been formed by detaching, that is potassium bromide and the water molecule. So this is how the product so called as propene will be going to form when 2-bromopropane will be going to get react with alcoholic potassium hydroxide. You are going to obtain that propene as the main product over there. Okay. Now let's take one little complicated example over here. That is the tertiary butyl halide. Tertiary butyl halide. So third example we'll take it. CH3, CH3, CH3. Okay, bromide I'll write down downside. Tertiary butyl halide, right? So bromide downside, and this is this. So the name of this reactant is, this is alkyl halide only, right? Tertiary butyl halide. Halide in the sense which halide is there? Bromide. So tertiary butyl bromide is the name of this reactant. Is the name of this reactant. Now here the question arises, now which is the alpha carbon and which is the beta carbon? Yes, obviously we know that. Obviously we know that the carbon to which the halo group will be there, that is considered to be the alpha carbon, and the neighboring carbon will be, yes, beta carbon, right? So this time this is also a quite simple one. When this tertiary butyl bromide is treated with alcoholic potassium hydroxide, they are going to get heated up. So that time from the alpha carbon we know that the bromide atom will be going to get detached. From beta carbon the hydrogen group will be going to get removed off. The beta carbon, whichever you want, this one or that one, that is up to you, because here the Sedgwick rule will be not going to get applicable. 3 carbon, if there are 3 carbon in the main chain, then the whichever carbon atom, beta carbon, you need to remove the hydrogen group, you can remove it off. But if that compound or the reactant is having a 4 carbon atom in the straight chain or the main chain, that time the Sedgwick rule will be going to get applicable over there. Okay. Now here the bromide atom which has been removed, yes, we know that it will be going to get attached with the potassium, and the hydrogen atom will go and get attached or react with the hydroxyl to form water molecule. So after removal or the detachment of those two groups, the product wherein it will be going to get formed over here is this CH3, this 2CH3 methyl group will not going to get disturbed out. So what is going to get disturbed out over here is the 2 bonds, they are going to get broken up and to form a new bond over here between the carbon number 2 and carbon number 3, that is basically, or carbon number 1 and carbon number 2, I can take like that in the reverse manner, alpha carbon or beta carbon, and the 2 hydrogen will be going to get remain as it is, this. Okay, so this is carbon number 1 and this is carbon number 2, right? So, and the product which is, the byproduct which is going to get formed over here is KBr, potassium bromide, and the water molecule. So the name of this product which has been formed over here is, you can make this as the main chain. IUPAC name we'll write down here. 1, 2, 3. 3 carbon. So the IUPAC name for this olefin or the alkene is, now since 3 carbon is there, at the second carbon the methyl group is attached. So it is 2-methyl 2-methyl. Now 3 carbon and the olefin it is, right, alkene it is. So 2-methyl prop in means what? Double bond. The double bond is present between carbon number 1 and carbon number 2. So you have to take the lowest preference of 1. So prop 1 in. This is the IUPAC name of this olefin, or the common name for this olefin is isobutylene. So this is how the product will be going to get formed. Now we'll take the example, next example, the fourth example, where the Sidzeff rule will be going to get applicable over there. Now we are going to study the new topic so called as Sidzeff rule. Now how the Sidzeff rule will be going to get applicable for the 4 carbon atom oriented compound or the alkyl halide. Okay, so if there 4 carbon atoms will be there into that long chain, how this rule will be going to get applicable, that we are going to study. Now let's take the reactant when 2 molecules of alkyl halide, 2 molecules which alkyl halide we are going to take over here, 4 carbon atom chain, right? So this is 1, 2, 3, 4, right? Now I am going to split and show you guys. At second carbon I am attaching the bromide group, and the remaining one you need to balance it out by adding the number of hydrogen atom over here. Okay, so the name of the alkyl halide wherein it's written on the board is, if this is the first carbon, second carbon, third carbon, fourth carbon, the name will be as such. At second carbon the bromo group is there, the bromide group is there. So 2 bromo and parent alkane. Parent alkane means 4 carbon oriented alkane was butane, right? So 2 bromo butane. So this is the alkyl halide. This is the alkyl halide at which the second carbon atom, the bromo group is, or the halo group will be going to get attached. And as we know, whenever the halo group is attached to that particular carbon, that is considered to be the alpha carbon, right? So this carbon number 2 is considered to be the alpha carbon, and neighboring carbon towards the alpha carbon, those are beta carbon. So I'll consider this as beta 1 and the another one as beta 2. Okay, now when this 2 molecules of 2-bromobutane or the alkyl halide is treated or reacted with the 2 molecules of potassium hydroxide, alcoholic potassium hydroxide, they are going to get heated up to form an olefin. 2 olefins are going to get formed. Why it is so? Let's see over here. Now first, from alpha carbon, yes, the halo group will be going to get detached, removed off. From beta carbon, the hydrogen group will be going to get removed off. But since here 2 beta carbons are there, right? So first I am going to remove the hydrogen atom from beta 1. So first from beta 1, the hydrogen atom I am going to remove out, right? So the product after removal of beta carbon hydrogen atom, what it will be going to get formed? Let's write down over here. So first carbon, second, third, fourth. Let's write down the number of carbon chain. Now this bromide atom or bromide group will go and get attached to whom? Potassium, as we know. So it will form potassium bromide. That I will write down later on, because since here 2 products, 2 olefins are going to get formed, that's why 2 alkyl halide group we are going to get react with the 2 molecules of potassium hydroxide. So the 2 potassium bromide and 2 water molecule will write down later on as a byproduct. The main product we are going to focus over here. So now since we are not touching the beta 2 carbon, right, beta 2 carbon, the number of hydrogen atom will be remaining same. Okay, from alpha carbon and beta 1 carbon, the 2 groups are going to get removed off. So the beta alpha carbon will have only hydrogen atom, and beta 1 carbon will have 1 hydrogen. I repeat once again, from alpha carbon the bromide atom is going to get detached, whereas from beta 1 the hydrogen is going to get removed. So these 2 bonds will be going to get broken up. So only 2 hydrogen will be there at this position, at alpha and beta 1. right? So here it will form new bond after the breaking of bond over there. To remove that bromide and the hydrogen atom, the bond will be going to get broke, and the new bond will be going to get formed between alpha carbon and beta 1 carbon, right? And the remaining last terminal carbon will have the same number of hydrogen atom which is there in the reactant. Okay, so this is the first product which is formed by the removal of hydrogen atom from the beta 1 and the removal of bromide atom from the alpha. So the name for this, so let's write down the name for this. This is 1 carbon, this is 2, this is 3, 4, 5, right? These are the numbering you have to give in this manner. Why in this manner? Because if you give from the reverse manner, this becomes 1, 2, 3, right? The same thing it will become between 2 and 3, the double bond will be there, okay? So the name for this is but, yes. At what position in is there? At what position the double bond is there? Yes, between 2 and 3. Now, you have to take the lowest preference, which is 2. So, but 2 in is the name of the olefin which has been formed over here. Okay, so this is the first product. Now, let's talk about the second product. Now, once you removed from the beta 1 the hydrogen atom in first product, now we'll remove the hydrogen atom from the beta 2. From beta 1 we removed initially, now we are going to remove the hydrogen atom from the beta 2. Okay, so once you remove the hydrogen atom from the beta 2, how the product will be going to get formed? Let's write down over here. So, let's write down the number of carbon atom, 4 carbon atoms. Now, initial carbon number 1, from beta 2 carbon atom, hydrogen atom is going to get removed off, right? So here double bond will be going to get formed, because from here alpha carbon bromide atom will be going to get detached. So these two are going to get detached and they are going to get combined with the respective potassium and the hydroxyl to form a byproduct. Okay, so this will be CH2, whereas the second carbon, that is the alpha carbon, will have only one hydrogen atom, and the remaining one you need to satisfy with the number of hydrogen atom has there in your reactant side. Okay, so only the beta 2 carbon and the alpha carbon will be going to get disturbed, because the bond will be going to get broken up over there. Okay, so the name of the second olefin which has been formed over here is 1, 2, 3, 4, right? So the double bond is present between carbon number 1 and carbon number 2. The double bond is present between whom? Carbon number 1 and carbon number 2. So the name for this is but 1 in. Why so 1 in? Because the lowest preference is 1. Okay, so these are the two products which has been formed by the dehydrohalogenation process of alkyl halide. Now the byproduct which has been formed over here is the byproduct which has been formed over here is 2 potassium bromide and the 2 water molecule will be the byproduct. This will be the byproduct. So this 2 product which has been formed over here, right? Now which will be the major product and which will be the minor product, that will be going to get decided by this Sage-Jeffs rule. Now what this Sage-Jeffs rule says, now between alkene, the double bond, between the double bond carbon atoms, the product in which more number of alkyl group will be there between the double bond carbon atom, right? The product in which more number of alkyl group will be attached between that 2 double bonded carbon atom, that product is considered to be the major product. I repeat once again, the product in which the olefin in which more number of alkyl group is present between the doubly bonded carbon atom, that product is considered, or that olefin is considered to be the major product. Let's see over here, then you will understand more precisely. Now in first product olefin, now this is the carbon-carbon double bond. Now between these 2 carbon double bond, carbon number 1 is having methyl group. This is 1 alkyl group. Okay, let's write down over here. Let's write down, then you'll understand more precisely. Okay, so this is the 4 carbon atom. Let's write down this. Okay. Okay. Now this is but2in. Now in but2in, you can see this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So the double bond is present between carbon number 2 and carbon number 3, right? So between these two doubly bonded carbon atom, sidewise you need to see, right? In this product there are two alkyl groups. One alkyl group is this methyl group, the another alkyl group is methyl group. CH3 is methyl group. So two methyl group there in the but2in. How many methyl groups are there? Two methyl group. Okay. Now let's see towards the but1in. Okay. Now in but2in, you guys have been understood there two methyl groups are present over there between the carbon-carbon double bond. Okay. Now but1in, let's draw the structure and understand once again over here. Okay. Now this is but1in, which I am going to write down once again over here. Okay, this is but1in. but1in. In but2in, two methyl group was present as a periphery towards the carbon-carbon double bond. Now here the double bond is present between carbon number 1 and carbon number 2. Now here how many alkyl group is present? If you see that CH3, CH2, this is one alkyl group. C2H5 is a ethyl group. C2H5 is a ethyl group. So here totally 2 carbon and 3 hydrogen means only one alkyl group is present in the olefin so called as but1in. Whereas in but2in, 2 alkyl group was attached, right, as a periphery towards the carbon-carbon double bond. So therefore but2in is considered to be the major product according to the Sidzeff rule. So but2in is considered to be the major product with 80% percentile, whereas but1in is considered to be the minor product with 20 percentile. So this is how the two product will be going to get formed, two olefin will be going to get formed when the alkyl halide is treated with the alcoholic potassium hydroxide to form two olefin with so called as but1in and but2in. And by application of Sidzeff rule, we concluded that but2in is considered to be the major product with 80%, where but1in is the minor product with 20%. So this is how this Sidzeff rule, the dehydrohalogenation process will be going to take place.